Hello, surely you have heard before about Newton's laws of motion. Today we will give you simple practical examples of these laws with a simplified definition. First law, an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. To understand more, watch this video. This ball was shot. We note that the ball is in motion, but when it hits the net, it stops and falls and will become at rest. If we assume that the goal nets did not get in the way of the ball, and did not get in the way of any other force, the ball would have remained in continuous movement. But in this video, the net force affected her and she did not stay in motion. And the opposite is true, this ball is in a state of rest. If no other force is applied to it, it will remain in a state of rest and will not become in motion. Second law, acceleration of an object is directly proportional to mass and force. Force is equal to mass multiplied by acceleration. This is a plane moving. Of course it has acceleration in this direction, and it also has mass and force in this direction. But how are these forces proportional? Well, we will answer this question mathematically this time. According to Newton's second law of motion, we conclude mathematically that if the force increases, the acceleration also increases. But if mass increases, then acceleration decreases. Law 3, before we give the definition, I want you to watch this video of the rocket launch. This force is in the downward direction, which is symbolized by blue here. It is the force of hot gas, which results in the missile rushing upwards with the force symbolized by red. But this time the force is in the opposite direction, and what if I told you that the upward push equals the downward push on the exhaust gases? Now you can read the definition of the third law. Third law, for every action, there is an equal and opposite reaction, and there is a more simplified definition. If an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. Subscribe to our channel to encourage us to post more.